Morning, everybody.
Good morning.
After class, Bonnie, when I'm done, got something I want to, I may have already asked you this, but stick around and I'll tell you what I'm thinking.
Sounds good.
Thanks. Okay, where we were at last time was on polynomials and dealing with those quadratics or polynomials degree 2. But then on polynomials of higher degrees, I think I was indicating that it tells you how many solutions that you're looking for. And sometimes you can find them with your calculator, sometimes you can't. Also, to possibly look at answers with multiplicity. We use the word multiplicity because you might have a duplication of the solutions. So got to indicate those as well. Today, we're going to say, hey, if we've got the same polynomials and you're trying to find the answers, I first go right to the calculator. And that's what I would do with, was it 2.3 that you were working on your homework? I go right to the calculator. If I can find them, go ahead and do that. That's fine. I don't need the algebra. In 2.4, it'd be the same concept. It'll say solve, find the zeros, find the solutions, which, by the way, if they're real solutions, they're x-intercepts. So find them, but in 2.4, you're not going to find them all with your calculator. Nice, exact. You won't find them all exact. So then what I'm going to show you is if you can find some using your technology, which you will be able to find the remaining answers, we're going to use what's called long division. Ugh. Some of you saying, I haven't done long division for a long time. You take a 1,000-digit number. No, okay, make it easier. You take a 7-digit number and you divide it by a 2-digit number. This is like 3rd grade math. How do you do long division on that? My grandson's doing that. You won't be doing that with numbers. You're going to be doing it with polynomials. How do you take a binomial and divide it into a polynomial that has, let's say, 7 terms? So that's what I'm going to show you, is that technique. And then what it gives us at the end is going to be crucial, because that's going to help you find your remaining answers. So let's just get started and see what I'm talking about. Okay, let's see, advanced here. So going back over here maybe and say, hey, okay, there's some answers. Find the zeros. I'm looking for the answers. There's 4 answers that I'm looking for right here, 4, 4, 4. So use your calculator, you might find all 4. 4 answers. What if you were able to find 2 with your calculator, 2 nice ones? You got 2 left over. So if you can find 2 of them out of the 4, that's a good thing. That's what I'm going to show you today. And then you're going to use this technique called long division. And then when you get done with the process of long division, you're going to end up with 2 more answers you're looking for, and you're going to use the quadratic formula. Now, we've done the quadratic formula numerous times, the beginning of the semester, and we probably also did it, 2.2 in quadratic functions. So it isn't new, it's just getting there to find the last 2 answers. So if I look at this one, for instance, this first one, I'm going to take this polynomial degree 3, and I know there's 3 answers. So when I go over here and I say, now when I say 3 answers, it has, if I said, hey, what's x cubed plus 4x squared subtract 5x minus 5 set equal to 0. That's what I'm talking about. It's got 3 answers, and you're going to find out that they may not all be real. They may not all be x-intercepts. And we know that x-intercepts are the real answers. What if they weren't? Then they're called imaginary answers. So complex answers. Complex answers, imaginary answers, they always come in pairs. They're called conjugates. So you can't have an odd number of complex answers. That's impossible. You'd either have 2 or you'd have 4. So with a degree 3, there's 3 answers. It could be that 2 of them are complex. It could be. And then there's only 1 x-intercept. But it would be impossible to have 2 x-intercepts and 1 complex that give you 3 total. It's impossible. So at least you have that knowledge. All right, well, how do we find maybe one answer? Well, this is what we're doing is we're learning how to do the long division and say, how does this process work to get us to that conclusion? And so let's do the long division. Put this aside. For right now, and then I'm going to show you how to take x cubed plus 4x squared, subtract 5x. Notice it's in descending order of power. That's going to be helpful or necessary. So how do you do this? My algebra, beginning algebra course, we avoid, because it's pretty, for them, algebra, it's pretty intimidating to do this long division. So I choose not to do long division with a denominator being a binomial or bigger. We only do monomials. And if it's a monomial, like with just x, what if I had all this divided by x? It's a simple thing to split it up into fractions, 4 fractions. Split it up. Because if I split this up into 4 fractions, each one of these fractions would have a denominator of x minus 3. Now in calculus, and Bonnie can probably attest to this, I can't remember if that is a 1B now or a 1A. It's been a few semesters since I've done it. It's called partial fractions. Bonnie, do you remember partial fractions or have you got to it in 1B? Maybe it's a 1B topic.
Yeah, partial fractions. 1B, first half, we've already done it.
Got it. So they'll deal with a technique if you had x cubed divided by x minus 3 and a calculus way of how to deal with that. But you don't have that because you're pre-calculus. So I need to show you long division. So you take the x subtract 3, do it this way. This would be x cubed plus 4x squared, subtract 5x, subtract 5. And here's the process. You want to make the x cubed go away. I'll say it again. I want to make the x cubed. I want to reduce this, and I want to use what I have. So up here, okay, this is called the divisor. X minus 3 is called the divisor. What's underneath this symbol, it's called the dividend. Dividend, this is old-fashioned. Oh gosh, where would they introduce this idea? And my grandson hasn't heard this. Maybe middle school, 7th, 8th grade. Quotient, you've heard of quotient before. That's a common phrase. Quotient's like it's a fraction, it's a ratio, it's the result. I like the idea of a result. The quotient would be up here. That's the quotient, the result. So divisor, dividend, quotient. I need some part of the quotient up here and to match this up, for instance, x squared, and then you distribute. If I had x squared right here, well, why do I put it there? I could put it anywhere up here. There's no rhyme or reason of the position of this. I just stick it above that because it helps guide me. But, you know, if you prefer to put the x squared over here, I don't care. It's just you're still doing the distributive property to create the x cubed. So x squared times x is x cubed. But then you say, don't forget the 3. 3 has been invited to the party as well, and the party is taking the x squared and giving it to the 3. So now I get negative 3x, and I want to line it up here. So minus 3x squared. Now, if I, this is positive x cubed, if I add it straight down, it doesn't go away. I want to make it go away, so I want to subtract. But if you subtract one of them, you have to subtract both of them. If I subtract, and this is the technique you want to do, if I subtract this from the top to make it go away into 0, 0, then you have to subtract the other piece. So don't forget to put the parentheses around it to remind you. Gosh, which then if you distribute it, that's going to be 7x squared ultimately, and then you bring these two pieces down. So minus 5x subtract 5. And you do it again. So what I'm trying to do is take a x cubed, or a degree 3 polynomial, and reduce it down to a degree 2 polynomial. Eventually it's going to be a degree 2 polynomial up here. See, a degree 3 polynomial divided by a degree 1 polynomial should give me at the end a degree 2 polynomial. That's true. If I had a degree 3 polynomial divided by a degree 2 polynomial, if this is an x squared, what's left is a degree 1 polynomial. Okay, I want to match up the 7x squared with an x. So how about a plus 7x? Plus 7x. So 7x times x gives me what I want to make go away. But don't forget over here, that's minus 21x. Line it up. Don't put the minus 21x over there. I would do it here. And then subtract both of them. This goes away. Let's see, that's plus. So that's looks like what, 16? I think it's 16. 16x, and then bring this down, subtract 5. And then we do it one more time. Looks like a 16. So you go plus 16. 16x.
26.
Say again, Farbad.
Is the negative 26?
Thank you. I made a mistake. Thank you. Let's see if I made a mistake. I don't think so. And here's the reason why I say I don't think so. I'm going to take this negative and give it here, and then I'm going to give it there. So that makes it a positive 21, and then subtract 5. Yeah, I think positive 16. It's positive 16 is correct. You just forgot right here to distribute the negative. That's good. I appreciate you stopping me and asking the question or challenging me, because there are occasions that I make a mistake. So thanks for stopping that. Okay, bring that down. What am I doing? Okay, oh, 16. 16 times 3 is 48. So minus 48. Okay, got to subtract both of them. And this goes away. That's what I want. See, these go away. These go away. That's what I want. Negative 5, and that's a plus 48. I think plus 43, positive 43. This is called the remainder. So you have a little piece, and some, gosh, my grandson, when he does problems that look like this, he's doing problems that look like this. The 36 divided into 4,622. He's doing problems like this, and his instructor, which is fine, says you get an answer. Well, I can show you how this works. 36 into 46 is 1. So 36, and you go subtract. And that's what? 1, 0, 2. 36 and 102 is 3. 3. Nope, that's too big. That'll be 108. So 2. 72. Subtract. 302. Let's see, the 9, 8, 8, 9, 27, 54. That's too big. So I think it's 8. 8 times 6 is 48. 24 plus 4 is, I think that's right. Subtract. This would be a 4. Borrow here, 9. I think it's 14. I think the remainder 14. So he's been trained to say remainder 14 like that. That's the way he's been trained. I reminded him, because he was asking for his homework help last night. Well, I don't know if I reminded him. I showed him that actually the remainder 14 is really, it's 128 and 14/36. It's 128 whole pieces, and this is the remainder 14/36, which can be reduced. So it's like plus too, by the way. It's a whole part plus that. So for you, you're going to go x squared plus 7x plus 16. If you said remainder 43, it's not wrong. It's not wrong. But the back of the book and the correct probably answer on the test is going to be x squared plus 7x plus 16 plus, that's a positive, 43 over x minus 3. So this would be, that would be your quotient rather than this.
So the remainder always goes over the divisor.
Sounds like Zach, did you have a question or a comment?
Just real quick, the remainder always goes over the divisor, just so that I can write the notes.
Is the remainder, what was that last part?
Does the remainder always go over the divisor?
Yes. Yes.
Thank you.
Yes. Similar to what I, was showing you. Okay, looks like 5's the remainder. And see how they do that? So just like you said, Zach, remainders over the divisor. And that would be your result like this. So for us, long division of polynomials, they take a problem that looks like this. See, it's a degree 2 polynomial divided by degree 1. The answer should be a degree 1 polynomial with maybe a remainder. And so they go over here, and then they're showing you all the process that I'm sort of doing, blah, blah, blah. Okay, but see here they have a remainder 0. Okay, you don't have to put 0 over the divisor, don't need that. It's just 0. Here's a result. I don't know if you can see that. See how they got the remainder right here? So you got the quotient and the remainder. The quotient and the remainder. So there's your divisors. 3x minus 2. See, 3x minus 2 is divisor. So for today, that's what we're doing. We're doing long division, and there's something special about a problem where the remainder is 0. Something very special about that. And you're saying, well, what is it, Jeff? I'll get to it. I'll get to it. When I get to it, then I'll explain. I'm going to have at least one in here that has a remainder of 0. This time I'll line it up right here. X times x is x squared. X times 5 is 5x. 5x, not 15. That was silly. Three plus 3, because 3 times x is 3x. That's what I wanted. Aha, remainder. Well, here's the first one. It comes out to be a remainder of 0. So what this is telling me with the remainder of 0, this means two things. Let's see. The original polynomial can factor. Oh, that means this thing right here actually is factorable. Really? Yeah, watch. Okay, choices of 15. Hey, let's try the 3 and the 5. Yeah, see, the x plus 5 is a factor. That's basically what it's telling you. X plus 5 is a factor. And the remainder right here, not remainder, but the quotient right there is the other factor. So multiply these out, you get back to the original. That's what it's saying. That's one thing. The second thing that I'm eventually leading you to is if you set this equal to 0, if you set x squared plus 8x plus 15 equal to 0, and eventually we're going to do that. If you set x squared plus 8x plus 15 equal to 0, and you're asked to solve, then with this being a factor, of course, you set that equal to 0. -5. See, this, you set this equal to 0 and you can find a solution. X equals -5. -5 is a solution, and therefore another solution is found up here. You know, there's two answers here. One is found by knowing that set this equal to 0, and -5 is an answer. See, eventually you're going to find out when you graph this right here in your calculator, and if you found that x was equal to -5 was an x-intercept, if you graph this and x equals -5, then you can use this with long division to find the other answer. You can use this, and what you do is you bring the 5 over, so you have x plus 5 set equal to 0, and now that's your factor, which is your divisor. And then you do long division on the original. So eventually, you're going to have a problem. Says, all right, find all the answers. Eventually, it's going to say, find all the solutions. Find all the answers. See it right here. Eventually, here's a function, and it says, find all the zeros. Okay, there's supposed to be 3. Okay, and it says, given that 2 is a 0. Oh, well, if you graph that, in which we will in a moment, it should show you that x equals 2 is a x-intercept. It should. So if x equals 2 is an intercept, then use that fact with long division to reduce this to a quadratic. And that's when you have a quadratic, you can use the quadratic formula to find the last 2. Okay, I'm getting a little ahead of myself. What do I want this one to say? That means not only can it factor, you also know that x plus 5 produces, no, I don't want to say produces, is, I don't like this, x plus 5, a solution. X-intercept. I still have. Really, x plus 5 isn't the x-intercept, but if you set it equal to 0, it does mean that it's it leads you to the 0. This is clumsy. I don't like that. That's true, but this is also, I'm trying to put it in words and it's not coming out very good. So sorry about that. It's a nice thing. Let's just say it's a nice thing. Remainder 0. Well, Jeff, what about this one? That's not the one that's factorable, you can do the distributive property, go backwards. Okay, what about this? Well, if I took x minus 3 and multiply it to that, then I should get back to the original. If I took the 2 factors that are right over here and multiplied it together, I get it back to the original. If I took these 2 pieces with the remainder 0, then I get back to the original. If I took, it's messy, it's messy. It's messy, and I take all of this, I would highly not recommend, don't take each piece and give it. I mean, it feels like that's what you should do. I understand that. But when you take the x minus, or just plain old x and give it over here, it gets really messy. So I would do all of it to that piece, all of it to that piece. And this is where the magic happens. All of this to that piece makes the x minus 3 go away. If I took x squared, x minus 3, and I took plus 7x times x minus 3, and 16 times x minus 3, and then plus 43 over x minus 3 times x minus 3. The magic happens here. And then you can distribute collect like terms and you'll get back to the original. It's just a lot of work. The nice thing is you're not going to be asked to do that. To check it, you're not going to be asked. Just know the process and how to get the right answer would be the key thing. All right, let's take a look and do this one. X plus 2. Ouch. And make that go into. Oh, well, this one here is missing the x squared. You notice that? It just slipped my mind. I just wrote it all out. You need a placeholder. If you're missing any term in descending order of power, put in a placeholder here. That's a recommendation. I think the author does the same thing. It's pretty typical. So the placeholder would be 0, x squared, and then put your 6x, and then finally the 8. There. Okay, now I feel better. I've got some place for 2x. It's going to be 10x squared to sit underneath. This is 10x squared. And then you go subtract, and then you say, this is what I wanted. And the negative goes with the 10. So negative 10x squared, and bring down the rest is what I do. And now we do it again. Get rid of the negative 10x squared. Okay, minus. Oh, I have x to work with, so convenient. Gets really challenging, by the way, when there's a numerical coefficient that's right in front of the x. If there was a 3 right here, if there was a 3 right there, and of course these would change, but let's say 3, and I'm trying to make a 10. 3 times nothing is 10, except unless it's a fraction. Well, then it becomes fractions in the quotient, and then it's challenging. Now, there's a way to avoid it. If I come to a problem like this, I'll try to show you if it becomes difficult. There's a trick that you can do to always make this into a 1 to begin with. There's a trick, but right now I think all the problems you're going to have will have a numerical coefficient be 1. All right, so negative 10, so that's negative 10x squared. That would 10x. Thank you. There you go. Minus 20. Gone. Okay, now that's plus 26x. 26x plus 8. Okay, I need a 26, so plus 26. 26x, and that's 48, no, 52, 52. Minus 44. And I think it's minus 44. 58 plus 40, I think that's right. So then you go subtract 44 all over x plus 2. Pretty mechanical. So the answer is this right here. Okay, this one's a little bigger. Missing something in here, so I'm going to go x subtract 2 placeholder. I need these two guys. That's negative 24 x cubed minus 24 x cubed. So it's very convenient to have a 1 right here because you can always make this thing go away. Very convenient. Ooh, 2 times 96.
Jeff, wouldn't that be 99x?
Yeah, thank you. Let's see. Right in here.
Yeah, 96 or 90. Oh, negative 3x plus 96. You're right. You're right.
There you go. Thank you for checking me though, Devin, or challenging me. Yep. This is very easy for any of us to make a little arithmetic error. Easy to do, especially when I'm doing it. I'm doing mine mentally. I'm doing. See, what you might want to do is just use your calculator if you want to make sure. But mentally, I'm easy to make a mistake. Let's see, 187. Let's see, today is the 13th. Okay. We will have a little quiz today, by the way. We're going to have a little bit of time. Number 7. I'm just looking at the assignment schedule for me. And it'll be based on 2.3, which would have been yesterday's homework. So which I have time to finish up what I've got, but there'll be a little quiz today, number 7. Where are we now? Okay, here we go. I think this is the last one of the long division one. And then I think I might have 2 problems left. Yeah, left over here. So this is missing a lot of terms. So I'll insert the 0x cubed and a 0x squared and a 0x. So again, what am I doing? I'm taking this piece right here that I just circled and giving it to both of these pieces. So 3x squared times x is 3x cubed. Then I'm lining this up, which is a good thing because I'm going to make that go away. And then -3 times 3x squared is -9 x squared, and I'm lining it up with the x squared piece. And then you always subtract parentheses though. And that makes the piece that I want go away. But then you continue on bringing the negative in, distributing it. That's a positive 9x squared. And then I bring down the rest of it. So no remainder. Okay, fine. You don't, there's your answer up here. And what no remainder means right now for you guys is this actually factored. X, nicely, x to the fourth. Hey, I'll remind you how to do this, by the way. X to the fourth, subtract 81. X to the fourth, subtract 81. This is a hard one for my beginning algebra students when they're learning factoring. This is easier for a math 156 class, which was the precursor to this one, because this is the difference of two squares. X to the fourth minus x 81 is the difference of two squares. So it looks like this. So it'd be x squared. They look identical, opposite signs. +9, -9. And then that's prime, so you can't factor that anymore. But this one here, I could factor this into the difference of squares again. See, here's your x subtract 3 piece right here. And if I took this piece right here and this piece right there and foiled it, you would get this piece right here. So x subtract 3 is part of the factor because it's a remainder of 0. And then the leftover, which is these two binomials, what you're getting is the expanded version of those two binomials right there. Only because the remainder is 0. Okay, last two problems. Okay, so we're going to solve. That means we set this equal to 0. And I'm telling you 2 is an answer. Now here's how you know if 2 is an answer. If I go f of 2, does it give me 0? Okay, 2 is a solution. Really? So f of 2, and then I'll show you the graphing calculator. 2 cubed, subtract 5. Uh, 816, subtract. Okay, that's 5 times 4, so 20. And this is 4. Yeah, 0. So that's one way of demonstrating that 2 is an answer. Another way is if I took my graphing calculator and graph this right here. It looks like there, that's probably a little better. There's a glare from, let's see if this works. Nope, worse. Yeah, I see a white spot right there. So do you. Just trying to make this work a little better. So 2x cubed, and then subtract 5x squared plus x plus 2. Okay, zoom standard. So what I'm saying is there's an answer right there too. Okay, how would you find it before? 0. Let's do 1.5 and 9. Yeah, okay, so 2 is an answer. What about the other ones? I wonder if it's 1. Curious. How about 0 and 1.5? 1's an answer. So there you go. There's another answer. And then you got another one over here. Oh, and that's easy one. That's -1/2. So all of a sudden I can come up with all the answers. -1/2, 1, and of course 2. But I gave you that right here. I said, hey, 2 is an answer. Now use that with long division and try to find all the other answers. So if 2 is an answer, the remainder should be what? If 2 truly is an answer, what should the remainder be when I do long division? Anybody? If 2 is an answer, and if I can write that as a factor, that's what you do. Subtract 2 from both sides, and then take x subtract 2 into 2x cubed, subtract 5x squared, and so on. When I'm done, what should the remainder be? Bonnie, what should the remainder be?
I go with 0 on this
0.
one.
I'd go with 0 as well. I'd go with 0. So let's see if that's true. 2x squared, 2x cubed, minus 4x squared. Cancel, cancel. Negative x squared plus x cubed. Negative x. Yep. Okay, now find all the zeros. There's supposed to be 3. There are 3 zeros. There are 3 zeros. So found one of them. So x equals 2 is one of the answers. It's one of the zeros. And to just demonstrate it, you already know that the other 2 answers come right out of your calculator. 1 and I think it was -1/2. So this can factor actually then, but I'm not going to do it by factoring. Most of the problems coming up, you can't factor it because they're really weird decimals. So the only way of finding those answers is quadratic formula. I'm going to use the quadratic formula on this. Okay, the opposite of b, plus or minus square root b squared Okay, so we have two answers. You've got 1 plus 3 is, what was that, 4 over 4. And you got 1 minus 3 is negative 2 over 4. And there are your two answers, 1 and negative a half. 1 and negative a half. So the quadratic formula will find your other two answers. So find all the solutions right here. You have x equals 1 is another one. This is equal to 1. And this is equal to negative 0.5, which my calculator gave me negative 0.5. This one here, polynomial degree 3, like this one was, 3 answers again, 3 answers. This one I want to start off by using my calculator to find a nice, like an x-intercept, a nice, hopefully number, nice 0. And then we'll use long division and we'll get it down to a quadratic again. So last problem. Looks like there's only one nice answer anyway. Well, nice, meaning there's an x-intercept. Kind of looks like it's 1. Let's see if it really is 1. Yep, it's 1. So x means because the y is 0. So x equals 1 is a 0. X equals 1 is a solution. Is a solution. I'm going to find them all. 0. And then we write it as a factor. And then you take the factor and divide it into the original. Oh, by the way, if in fact there is only one x-intercept, one real solution, the other two will have to be imaginary. So we'll see if that's true. Have to be imaginary. Let's see.
You have a positive x that was brought down from a negative x.
Ah, good. Thank you. Thank you for catching that. Good. So remainder 0, that's what I expected. So now,
Shouldn't it be positive 4?
right here?
Isn't it when you do the quadratic formula, it's negative b, right? Plus or
Yes,
minus?
thank you, Zach. You're right. You're absolutely right, right here. It's the opposite of b. So thank you. This would be 4. So this I forgot the negative on the outside. And that's 2 mistakes. Thanks, Bonnie, and then thanks, Zach, for catching that.
It wasn't
The opposite of negative 4 is positive 4. Yep. Six, 20 times 5 is 20. I'm running out of room, so I have to do it a separate piece of paper. I'll rewrite it over here. So I just rewrote this one. Okay, it looks like imaginary, which I suspected. Break this up into 2 fractions like we did back in 2.1. Remember the a plus bi form. I'm looking for that as well still. Okay, the I comes out, your author oftentimes puts it out in front of the radical. I don't. That negative in the denominator moves to the middle, which then it gets absorbed into these signs. So basically that negative right there, it's still a positive negative. That's kind of the point that I was making, plus minus. There's still a 10 down here though. I'll put the I over here. Let's see, 84 has got a perfect square in it. 4 times 42. And then 42, 6, 7. I think that's it. So I think it's 2 root 42. 4 times, no, that's not right. 22. 21. Funny. Okay, 84 is 4 times 21. Yeah. Yeah, the square root of 4 comes out as a 2. Yeah, root 21. And then final best looking answer. So there are your other 2 answers. You got x equals 1 and the other 2 are imaginary. Exact. That, I mean, the author wants them exact, and so do I. No decimal approximations. Any comments, questions about what we did today before I unshare my screen and we'll get started on the little quiz?
Hey, Jeff, I guess I have a little bit of a question, not really a question. So it was from last class. It was one of the problems that we were looking at. Let's see, section 2.3.
In my packet or a homework question?
In your packet, it was on the last page before we started long division. And it was the top one that you were talking about a little bit today. You didn't go into it, but yeah, that one. So basically, when we factor out an x squared, we end up with an x squared as a term that you can set equal to 0.
Yeah, break it up into linear factors though, Bonnie.
Mm-hmm.
So here's my suggestion.
Yeah, that's what I was hoping you'd be able to point out. The linear factors there with the x squared.
So then you take the first x and set that equal to 0. Take the next x, take each factor, set it equal to 0. See, it's the same answer, so you'd say it's multiplicity 2. X equals 0 right here so far. You have x equals 0 with multiplicity 2. That's what the author probably does. Or they might say it's a double 0. And then this one here. So here's 2 answers, and then you have x is equal to plus or minus 3. So then you got 4 answers altogether, which is what we wanted anyway. Your calculator will show those 2 very distinct roots or x-intercepts, and it'll show x-intercept being 0. So that's only 3 of them, but this one actually bounces. It'll look something like this without a calculator. You've got what, -3 and 3. Let's see, I think it goes like this. It's going to come back down. Bounces, bounces, bounces. Hello. It's got to come back down here. Goes through. Oh, like this, probably like this. I think it goes up. I think it goes the other way. Now that I look at the leading coefficients positive, I'm 99% sure that it goes like this. Because the A, the leading coefficient's positive, so the behavior is going to go up. If this was negative, the behavior goes down. So if you graph that, I think it's going to look something like that. So the point Bonnie's saying, I think, is you got 2 answers. If you just said x squared equals 0, you might say, x is 0. But you actually have to make a statement like that. Is that what you're thinking, Bonnie?
Yeah, how you broke it down into the 2 factors. That was the part that I was missing last class. And
Okay.
Just to add to that, what I read in the book in this section is that when it has an even multiplicity, as you pointed out, it just touches. And when it has an odd multiplicity, it crosses.
Exactly right. So if this was an x cubed right here, it's going to pass through the x-intercept rather than bounce. Yeah, so even multiplicity, it bounces. Yep.
Thank you.
Yeah, good. Glad you asked that. So Bonnie will be in her Zoom session after the little quiz if you've got any other questions. And let me release the number 7, looks like number 7. Well, no, this is number 7. You only got 3 more left for the semester. I'm going to open it up myself before, and just to make sure it's something you guys are supposed to be doing. Polynomials, symmetry. Let's see. Find the zeros. Yep. Okay. So there's only 4 questions. No, excuse me. There's 5 questions. Yeah, 2 points each. All right. Let's go ahead and publish. Okay. Anybody see those yet? That's number 7. Daily quiz number 7. Okay. Rochelle's saying yes. So is Selena. Okay. Let's get you into breakout rooms. Okay, it looks like groups of 3 or 4, like typical. There you go. So Bonnie, I'm going to ask you if you would make up the answer key for group quiz number 2 for me. Make up the answer key for that. And you should, I think, tell me if you have access. You can bring it up and see into my class as being a co-host, I guess, or a pal. If not, then I'll send it to you. Group quiz number 2.
I'll look right now. Yep, looks like I have it. I have the PDF for that one.
You do? Okay.
Access,
So
access to the PDF.
So that would be great. And then once you get it, if you could scan it to me, I'll just double check you.
Good.
And then I'll have you release that, send it to them after they take their group quiz so they have a copy of the answer key.
I can look on there and see when that's happening. Is that coming up here?
Yeah, we're getting closer to the quiz, probably a week.
About a week, it looks like. Okay. Alrighty.
Thank you for doing that.
Yeah. Thanks for going over that question. I know it's kind of a small details, but
No, if you ask that question, then others are going to have the same thought, you know. Well,
yeah,
no,
I ended up saying, well, we'll have to ask Jeff about that, you know, if you could have a multiplicity. I ended up with x squared equals 0, and I'm like, plus or minus 0, that's really weird. Like, I guess there's 2 answers.
Yeah.
I'm like, I'll ask Jeff about that one. And then, you know, I just looked through my notes and I looked in the book and I was like, oh yeah, of course. Like, why would it not be able to touch 0? It can touch any number. 0 is just a number in this case.
Yeah.
And then saw how you had done it last year when I was taking the class, and you've done that problem and you had the 2 x's multiplied by each other, and I was like, well, duh. You know, it can factor further. You can have x times x. So then it just, rather than leaving with everybody hanging with the like, well, we'll get back to you on that. It was nice to have you just sort of explain
Sure.
it.
Yeah, we had time to do it too.
Yeah, going well.
Something else next week. I think I might have mentioned. If not, then this is the first time you're hearing it. Next week on Tuesday, I will not be around, and Thursday too. It turns out. So Tuesday, did I say Tuesday? Tuesday and Thursday of next week, I have recorded the lectures,
Okay.
if in fact, I think take a look at the assignment schedule. Is a week from today the group quiz?
Yeah. Well, it looked like it was.
No, not a week from today, but today's Tuesday. A week from Thursday.
Okay, here's my assignment schedule. All right. Polynomial functions, long division, zeros to polynomials.
The revised. Make sure it's the revised.
Yeah, October 22nd is quiz 2. Group
20?
quiz 2, yeah.
Yes. Okay. So October 20th, next Tuesday, I still have a topic to cover, and I think it's 2.6. Is that right?
Okay.
Yep. So that's a recorded lecture. I'll be sending out a email to everybody that will indicate what they need to do, which during class time, that's the thought, during class time, go ahead and watch my recording. I've already created it on YouTube or through Zoom, but I've uploaded in YouTube. They'll have a
Okay.
link and they will then watch it. In theory, instead of seeing me live, they'll watch it in their privacy of their own home.
Okay.
And then they will be guided or directed, instructed by me to go find you. So you'll be available at your normal times before class and then after, and but they just won't see me. It'll just be recorded.
Okay, so like what is the normal time, like 10:15-ish or?
Yeah, 9, what is it? We start at 9. So yeah, 9 till 10, excuse me, at 9 to 10 to a 10. I think my recording's less than an hour.
Okay,
I'm real sure it's probably about 45 minutes. So they'll watch it, just figure on the time you usually go, which is around 10:15. You might want to send them out once you get my email, you get it, send them out a reminder. Hey, just saw that Jeff sent out this reminder. I am available still from 8:30 to 9.
Mhm.
And then our after class session, I will be available to answer any questions. So that's Tuesday of next week.
Good.
Then Thursday is group quiz. I'll send out another email to everybody. And of course, you don't need to show up for group quiz or class time, but I'll send an email and they will be taking their group quiz on their own. It won't be, hey, show up and do breakout sessions.
Okay.
So that's the way I'm going to arrange it. Release the group quiz like normal. Just take your time. Here's the deadline. So there won't really be any class. I'll just put it that way. There's no class on Thursday. And I can't remember, have you in the past offered after quiz time, I'm around? Have you done that before? I can't remember, or not.
Usually not. Usually I'm just not there. I think most of the people, once they do their quiz, they're kind of done.
They're spent. Okay,
Yeah.
so then just, if I remember, I'll say Bonnie is not around at the end, but if I don't, then just send them a message and say, you're on your own, I won't be available, or I'll be available one-on-one, just to remind you if you need any questions before the exam. But once the exam's released, you might want to remind them about that too. Once the exam's released, there is no, Jeff has instructed me, no help, even on homework, on anything during that 24-hour window of time.
Yeah, I think you made that pretty clear to them. I think you kind of scared them a little last time.
Yeah.
I heard from nobody the whole weekend before exam.
Don't
Okay.
do it. Yeah. Okay,
Yeah.
sounds good. So that gives
Yeah, I
you.
didn't even have any
what-
questions before the exam, which is kind of surprising, but I don't know. So yeah, I think the group quizzes are good study guides. So hopefully people will feel prepared with their group quiz. All right, so I'll put together the key for the group quiz and then send out messages about next week.
Sounds good. But otherwise, I will see you on Thursday. This Thursday.
Okay, yeah, this Thursday. There we go. Perfect. All right, I'll see you later, Jeff.
Okay, Bonnie. Bye now.
All right, Jeff, I'm gonna head out.
Okay, Camden. Take care.